Really going to talk about Docker networking. This diagram here is the Windows network with 2 Linux WSL hosts and 2 Docker pods running and an all plugged in on Ethernet. And I think I'm going to have to break this tog up. Anyway, so we're going to ignore the WSL routes at the top for a little while. That's actually the 2 WS. Like if you're doing Linux development, those Linux machines actually end up on the virtual switch. The WSL one. There's actually 2 at default in a WSL. So all the Linux all the Linux WSL2 instances end up running on that WSL internal network, and the switch is sitting on the Windows machine, and so you can transit from those machines through the internet through that switch. So I'm going to ignore that top row and then sort of the second one from the bottom is the home network. That's actually like my real physical switch off the FiOS, in this case at home. And so that's my 192.168.1. It's DHCP. So in this case, I picked up address 180. And so the Windows host in this case, we talked a little bit about the WSL network. It turns out it also ends up with like a virtual IP essentially representing that machine. And so that's sitting on the Docker desktop network, and then you have the home network I just talked about. So there's really 3 networks there that are attached, sitting on that host essentially, or you can route through that. And that really means there's, like I said, 3 different interfaces. You end up, in this case, we actually end up with 4 networks. 1 for the WSL. We end up with 1 for Docker desktop. We end up with 1 for my home network. And then it turns out Docker actually allocates a second address range for the containers themselves, and that's the 172.17.0 network. So all of the Docker containers actually run on that 172.17.0.1, and then they pick up addresses as they're created on that network. And then all the traffic that routes off of the Docker pool, address pool, off the Docker container network, those all go to the Docker desktop. If you do a trace route, these are 2 BusyBox instances. If you do a trace route to anywhere, the second step is always this gateway sitting on the Docker desktop network. So you have this private, truly private Docker address pool. That's why you end up having to do all these port forwarding and stuff. It's because you have these internal networks that are not necessarily visible, like this Docker address pool, right? It doesn't actually have address access to any Ethernet adapter directly. It's got to go through this Docker desktop network. At least that's what traceroute says. And then and the routes where you end up also depends kind of on the Dockers. They do this host Docker internal and gateway Docker internal, and what IP address that actually selects based on where you ask. So in this case, even though these 2 containers are sitting in the Docker address pool, if you were to do an NS lookup against host Docker internal and gateway Docker internal, you actually get the IP address that's sitting on the Docker desktop network, right? So that means if you want to ping or do a trace route to host Docker internal from the BusyBox or from the Docker containers, they're actually going to go across the Docker address pool network, and then it'll drop into the Docker desktop network. And then depending on what you asked for, it will actually end up on a different IP address on Windows 11, right? So if I were to say ping host Docker internal, gateway Docker internal from the Docker containers, those will route through the Docker address pool into the Docker desktop network, and then they will pop up on that virtual IP that happens to be on that network. Now, if you were to ping to go to 192.168.1 or like Z80, right? If you were to ping, I don't know if remember if that one works, but if you were to go by IP address, it'll still hop across the Docker address pool, end up in the Docker desktop network, but it'll end up talking to the Ethernet card instead. So that is still the same machine, but it's on a different IP address. And then there's a little bit of other routing, interesting stuff there. If you end up like pinging or trace routing, www.google.com. That'll still go across the 172 network from those pods, and then it'll end up on the Docker desktop network, and then it'll hop straight to the internet, right? Because because it doesn't need to go through the 1.180. At least that's the way it shows it. I suspect it. It's got to be on the it depends on how the network routes go, but it's got to go through the Ethernet card, and then it's going to go, in this case, that 192.168.1.1 is the FiOS router. So that's, 5 minutes. Okay, so really what I wanted to talk about in this, I guess we can look at the host names too, right? So Docker always says that you can try host Docker internal and gateway Docker internal, and you'll get connected to the host machine for Docker desktop. And that actually works. But you can end up with weird, different addresses based on where you ask from, right? So if you are on the Windows machine and you say host Docker internal, gateway Docker internal, I don't know how useful it is, but you actually end up on the regular Ethernet adapter, right? But if you do those from the Docker containers, those actually point all the way out to that Docker desktop network node that represents the Windows machine. And, there's some local host behavior and other stuff for Ubuntu and those things, but I'm not going to cover that. So again, the primary thing in here is you got a kind of a buried private network for the node pools, address pool, and then all that will transit through the Docker desktop network. And I think that's how they do the VPN routes too. They hide it in there, right? And there's DNS there, and this is just kind of like me playing with it. I'm sure that the addresses may not always be the same. There was this .4 address, the .5 address, and the .7 address. I didn't even look to see what .6 was. But that's how it works. And I will do another talk on the Linux, right? Which they actually sometimes can end up pointed at a different address for the same host name than what we got on the BusyBox. And I think that's because of the way the network route works. It still ends up on the same machine. But what it means is if you have a service listening on a port only on one Ethernet card, it might be reachable from the Docker containers, or it might be reachable from WSL, but it might not be reachable from both, right? If you do 0.0.0.0, which is all of the interfaces, then you're fine. I just wanted to point that out, right? You got 3 different addresses really that represent that Windows machine remotely, not counting local host or 127.0.1.1. And so you can end up with slightly different behavior depending on what port you're listening to. So really, this whole thing was, hey, look at this cool chart. It might be useful to you.